the last section of chapter 6, so the last sort of thing we're going to talk about here, statistics, this is sort of the last thing in statistics, is what's called polling. Alright, this is when, again, it's the statistics of polling and understanding marginal errors and confidence intervals that go with the polling results. Alright, polls, or anything where we typically have taken a survey of people, typically would usually take a survey of people, or it can also involve when you're testing products and things like that, it can involve that as well. Alright, so what polls typically are is we will estimate the population's percent, or the population average, by taking a random sample of the population, because often it's hard to actually take an entire population's average, because a lot of times populations are large. And so what we do instead of taking, so again, like I said, even if we were talking about the state of Illinois, alright, there's like 13 million people in the state of Illinois, it'd be almost impossible to poll all those people. It would be impossible. Same thing with the United States, right? There are almost 400 million people in the United States. You could not take a poll of every single person in the United States. And so when they give you the polling numbers, right, when you're on the news or you watch an ad or you're reading a book or an article, and they give you these results and it says 40% of the population does this, that 40% is based on an estimate from taking a random sample of the population. And so that's what this set of notes is going to look at in 6.3. Alright, so again, it's a sample, and then we look at the sample's average and percent. To kind of put it in terms, so suppose we know that there's a population of a town, right, it's 100,000 people, and the percent of people who support a particular candidate is 40%, alright, so suppose that we know that's true, right, even though typically that's an unknown thing because we don't really poll everybody in the population. That means, right, what that 40% means is that if they polled the population, 400,000 people would say they like the candidate. 6,000 people would say they don't. Right, that's what it would say if we make that assumption. Right, but instead of actually polling 100,000 people, and again, even the numbers here wouldn't make sense because very rarely do numbers come out that nice and neatly in polls. Alright, because, again, you're not going to have exactly 40,000 and exactly 60,000. Alright, so what's done in real life is they estimate the behavior of a population by taking a random sample of a smaller group of that population. So an example would be, in this case, suppose that they base these numbers on a sample of 300 people from the population. Alright, they found that 120 of them, of 300, said that they support the candidate, and then 180 of them do not. And so what that turns out to be, if you take 120, that's 40% of the 300. If you take 180, that's 60% of the 300. And so then based on that, the small group, they make the generalization. 40% support the candidate, 60% do not. Alright? And again, so they generalize an entire population based on a small group. But usually, if the polling is done well, meaning the questions are written well, you've done a really good job of sampling. And what we mean by a really good job of sampling is you've picked a diverse group of people. Alright? A diverse age range, diverse ethnicities, diverse backgrounds, educated, higher educated, working class, white collar class, wealthy, middle class, poor. You've pulled a good sampling of all of the diverse groups in your community. And what you would prefer is to get the right percentage. So again, if you have a certain percent of a certain group when you poll them, you want to make sure you have a certain percent in your polling. Right? That would sort of be the perfect. Again, it doesn't usually work out that way, but that would be the perfect polling. But in theory, technically, if you're randomly picking, based on the law of random numbers, if you're just randomly picking people from a population, technically, you could pick 300 people that said they support them, even though if it was known that only 40% do, because 300 out of 40,000 is not that many. So you could have randomly picked 300 people and they all fell in the 40,000 group. Or you could have picked 0 people who support them, meaning you picked nobody in the 40,000 group, but you picked all 300 from the 60,000 group. Technically, that could happen. But, like I said, if you're doing a good job of randomly picking people from different groups, that's highly unlikely. But there is error involved, and I keep saying that, because there's error involved. We have to sort of figure out, well, what would be the biggest error, which is where marginal error is, and how confident can I be in this poll? All right, and that's where confidence intervals come in. And so that's what this section's gonna get into a little bit. I did post another video where a guy explains this in good detail, and I thought he did a good job of explaining it. So if you want to know a little bit more about it in more detail than what we're going to cover in 6.3, you can watch that video. I'm basically going to hit the highlights and what you need to know. All right, so that's what I'm going to do in my videos. All right, so the first thing is you kind of need to know where these numbers come from, right? Where do these numbers, 60% and 40%, come from when we're polling people? All right, well, those numbers are what's called the point estimate, polling numbers, and they're the percentage in the poll, in the sample that we've taken, with whatever desired characteristic we're looking for, whatever we ask them, right? Whatever it is they're asking for. And so how we find that, it's the same percentages we've been dealing with all the way through chapter 2. All right? It's always the part, the people in the poll who said yes or no, divided by the total, right? N is your total in the sample, polled. X is the number out of the sample who said the desired characteristic. Who answered the question the way that you wanted them to answer it. Said yes to the or no to that, or whatever it is you're asking. All right, and then we multiply by 100, so we put it as a percent, because it's a percentage of the poll. All right, so we'll do 2 quick examples. Suppose that we have a group of 400 children that we've polled. All right, so we've randomly selected 400 children. Out of the random group of 400, we asked them if they liked apples. All right, 325 of them said yes. All right, so that's the desired response. So calculate the percentage. So remember, the percent is, so this would be the X value, the number who responded the way we wanted to. This is the total, that would be the N value. So the percentage is X divided by N times our 100%. Write 100 down there. And so out of 400, 325 said yes, they like apples. That gives me the decimal, or the fraction, multiplied by 100% to give me the percent of those students, or the kids. And so you divide it out, and you get 81.25% of the children polled. All right, so again, of the group that we've polled, 81% of them said they like apples. And then typically, if we did it, we would say, that means 81% of children as a whole like apples. All right, but there is some error involved, and again, we'll talk about that more later. All right, the second example, suppose that we have a group of 500 college students. All right, we asked them if they attended a basketball game. Suppose that 100 of them attended a basketball game. Calculate the percent of students polled that attended the basketball game. Well, again, this would be the total, that's N. 100 would be the number who went to the basketball game, the desired outcome. And so it is X divided by N times our 100%. And so in this case, it would be 100 out of 500 went to the basketball game. Multiplied by 100%, so this comes out 20. 20% of the college students that we polled said that they were going to attend the college game. And then we'd make the assumption that out of all college students, based on this outcome, attend college games. Again, there would be some error involved. All right, but that would be the percent of my group. All right, it's always the part that we're looking at divided by the total number we've sampled. All right, we'll stop there. We'll pick up the notes in the next lesson video.